Welcome intellectuals to Siden Institute. In our today's tutorial, we are going to talk about binary operation. This is the topic which most of you have been asking me to teach, and I skipped a bit because my main focus by then was on functions. So now we can do this topic which we skipped. Alright, so actually binary operation, I may say it is also the simplest topic in MSM 11 semester 1. Okay, so I'm going to use the lecture notes which you were provided with by your lecturer, the one that I'm going to take you through so that you understand better what it actually means, because lecture slides are very summarized. That's why you need explanation. Okay, so first of all, you need to understand what does the term binary operation means. Okay, so the term binary, from the word bi, okay, bi means two. Okay, so this kind of operations involves two operations being done at the same time. Okay, this is an operation which involves operating two things, two operations. We've got a number of operations. For example, we've got operations like plus, minus, division. We got multiplication. We also have when it comes to sets, we have the intersection and the union set. So all these are operations. Okay, so now if we are doing two things at the same time, for example, when we are talking about laws of sets theory, we talked about how actually intersection sets distributes over the union set. So that kind of operation, for example, if I may take you through where we're talking about A intersection B union C, this was distributive law which was giving us A intersection B union B intersection C, actually A intersection C. So this kind of operation is what we are actually talking about, a binary operation, because it involves operating two operations in the same expression. Okay, so now there is a question which you are going always to receive. Okay, there is a question which you are going to receive. For example, you are going to receive a question like, is a star binary? Okay, is a star binary operation. So when they have to say that is a star, because when it comes to binary operation, instead of writing things like 1 plus 2, we are going to be using the property over 1 star 2. Now what will determine now, it is the expression which have been given. So for example, if they have been told to say that A star B is equal to A plus B, and you have been asked to find A star 2, that means to say where there is this will correspond to 1 and B will correspond to 2. So that means to say we're going to replace 1 where there is A and 2 where there is B, which is actually same as saying A 1 plus 2, we get 3. Okay, so now in case you have been asked to say that state if a star is binary, it is the same as they are actually talking about the closure property. The closure property. Okay, so this closure property, it talks about also a binary operation where we take two numbers from a set. Okay, let me even state this. So we take two numbers. Let's take two numbers from a given set. Two numbers from a given set, and we're going to produce a new number within the same set. Within the same set. Okay, so this can be written mathematically as, for example, if we know that A and B is a member of real numbers, and after taking into a certain expression, we also get a real number. Okay, we also get a number C, which is also a what? A real number. Just understand that the closure property has been what? Has been satisfied. What I mean is that, let's say for example, I've been given an equation to say that A star B is equal to, let me also use the same, A plus B. Now let me make it A, B plus C, 2. Okay, then you have been asked to say, you need to show if the closure property has been satisfied there. So what you are going to do now, on what? On set of real numbers. On set of real numbers. Has it been satisfied on set of real numbers? So what you are going to do is very simple. You know that real numbers runs from negative infinity all the way to positive infinity. You can take any two numbers within here, and it is very important we use numbers which are not going to confuse us when we start computing here. So with me here, I can rate, you say rate A is equal to 1 and B is equal to, you can even make it 2, for example. So we're going to replace in the expression there. That means in this case, A is going to be 1. So where there is A, you're going to put 1, and you're going to put 2. That means 1 times 2 plus this 2 here we are going to get 2 plus 2, which is actually 4. Okay, now we're going to ask a question. Is 4 a real number? Actually yes, because 4 is within the what? Within this set, it is within the real numbers. So when you take two numbers from a given set, be it a set of rational numbers, irrational numbers, complex numbers, be it a set of integers, and so on, and at the end you produce the same number from the same set, what we get is what? What we get, what we need to understand is that the closure property has been what? Has been satisfied. This is what you need to understand, guys, on this. Okay, so now, apart from closure rule, we also have many more rules which you need to understand. Okay, the other rule which we are going to talk about, let's talk about commutative rule. In your lectures, right, when I was going through the lectures, right, the first rule was associative law, but I start talking about commutative law. After I talk about commutative law, now we talk about associative laws. Okay, so on commutative law, guys, commutative law, it talks about the order doesn't matter. If we have A star B is same as B star A, and closure commutative law is very commonly understood when it comes to multiplication and addition, because when we have 2 times 2 is same as, let me say 2 times 3 is same as 3 times 2, at the end we will just produce what? 6. The order doesn't matter. If we start with 3 times 2 or we start with 2 times 3, we still get what? We still get 6. And that's the same, the opposite is true. When we say 2 plus 3, we get 5. Also 3 plus 2, we also get what? Get 5. So that's all about commutative law. So understand that when we have A star B is same as B star A. So we are going to understand this better when we try to do any question. Okay, but the good example is this which I've just shown you here. Alright, so the other rule which you need to know now is associative rule. Okay, an important reminder is that multiplication and addition, as I said, are commutative, yes, but subtraction is not commutative. And this is true because if we say 2 minus 3, we get negative 1. But 3 minus 2, we get 1, of which 1 and negative 1 are not equal. So minus is not commutative, but positive subtraction is not commutative, but addition and multiplication is what is commutative. This is what you need to understand. Okay, let's now go and understand what actually associative rule states. So let's talk about associative. Say associative law. Okay, associative law also it actually also talks about now in this case we are going to have, instead of only having 2 here, we are going to add C, and I'm going to explain this. It states that A star B star C there is equal to A star B star C. But what is going to differ in this case is the order. In this case, we are going to start with A star B, okay, then star C, which is the same as B, A star B, then star C. That means to say the order here doesn't matter. What does that actually mean? It means that, and also associative rule is also true with the addition and multiplication. A good example I can give you guys is that when we have, let's say for example we have 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. When we start with this, here we start with this. Let's see if we are going to have the same thing. 1 plus 2, we start with what is in the brackets. When you follow body mass, we get 3. Then plus what is outside, we actually get 6 here. Let's come here. We have 1. What is in the brackets? 2 plus 3, we get 5, which is at the end we get 6. So that is what actually associative rule. So go ahead and try with multiplication. Okay, let's say for example we had multiplication here. We had 1 times 2 times 3 is equal to 1 times 2 times 3. Now in this case we start with here, here we start with here. Okay, 1 times 2 we get 2 times 3, then here 1 multiplied by 2 times this, we get 6. Okay, so let's say 2 times 3 we get 6. Also 1 times 2 we also get 6. So multiplication and addition are associative. Understand that. So whenever we are asked to say if star is associative, just understand this property. Okay, it just talks about the order. This is the same guys I was telling you about when we are talking about sets, so that when you are talking about A intersection B intersection C, okay, is same as A intersection B intersection C. Okay, this is one and the same about associative rule we talked about on sets is the same as the same associative rule we are talking about on binary operations. Okay, let's go ahead now and talk about distributive law, which is actually number 3. We said distributive law. Okay, distributive law now is going to talk about how different sets, how different operations distribute over the other. Okay, for example, a good example I like giving is how multiplication distributes over addition or subtraction. Let's say for example we have okay, let's say for example we have A multiplied by B minus C. Okay, what do we do, guys? We are going to say A times B here. We're going to have A times B, then minus the sign which is in between here, the one we are going to have here, and we say A times C. A times, we multiplied by C there. So this rule now is going to be true. It's going to be true now when we are going to, instead of us now replacing multiplication and minus, we are going to say now A star. Now the other operation, instead of having another star, because if we replace a star, we are going to have the different row, of which it can't even be well defined. So what we are going to do, we are going to say here, instead of having star, we are going to have another operation which is going to be O. Okay, which is actually be written as, let's just be reading this as a circle. So A star B circle C there. Okay, we get, so we're going to multiply A times B there. We're going to have A star B. Then the one which is in between here is like minus, which is going to be in between here. We're going to have O, then A star C. This is how you guys, you should be able to understand what is actually distributive law is. So in case you have to show if distributive law exists in that binary operation, you need to use this kind of error. You need to know this. Okay, and you shouldn't struggle too much to understand this, because it is one and the same, like the way I've just shown you with the multiplication. So you can be using this one to understand more. Alright, so now from here, let's go ahead and understand what actually an identity element is, because it is very important. In an exam, you may be asked to find an identity element, or you be asked to find the inverse. And the important part about finding an inverse, I'll talk about this. You can't find an inverse if the identity does not exist. And for you to know if an identity does not exist, you need to know how to find it. So it is very important that you know how to find an identity element. So an identity element, guys, doesn't change anything if you operate it with what? With a certain number. Let's say, for example, we say that 1 plus 0 is equal to 1. Okay, let's say 2 plus 0 is equal to 2. Then 4 plus 0, we get 4. What are you seeing, guys? You are seeing that even if we had 0 to any number, the any number is being repeated as the answer here. So 0 is an identity of any number when it comes to addition. Okay, it is an identity of any number when it comes to what? To addition, because even if we had 0 to any number, be it 100, negative 2, any number, the same number will be repeated as the what? As the final answer. So 0 is an identity of any number. Okay, when it comes to multiplication, okay, when it comes to multiplication, even in subtraction, when we subtract 1 minus 0, so even here with the subtraction is one and the same. When we say 1 minus 0, we get 0. 2 minus 0, we get 0. Actually, we get 1 here. We get 2 here. Then 4 minus 0, we still get 4. So now, an identity element when it comes with multiplication is actually 1. What does that mean? I mean to say that when we say 2 multiplied by 1, we get 2. 3 multiplied by 1, we get 3. And 4 multiplied by 1, we get 4. So multiplying 1 to any number, the answer is the n number. So we just see n multiplied by 1, we get n. Or n plus or minus 1, we get what? We get n. So now, what you are going to say is this. This is going to be an identity. Okay? Sorry, here we have to have 0. because when we say positive or minus, so we get 0. So that number which is not having any impact on the operation is an identity element because it is not changing anything. So now when it comes to binary operation, it means this, guys. It means this. It means to say when you are operating A star E, commutative row is telling us to say 1 plus 2 is same as 2 plus 1. So I'm not going to confuse anyone when I say A star E is same as E star A, because that is what identity element is telling us. I mean commutative row. Now, identity element property is going to say that if E is an identity, okay, we are going to write in this case E to be an identity element. To be an identity element. So that means to say if we say A star E, this E is not going to have an impact on A. Just like the same way 1 minus 0, 0 has no impact on 1, we still add 1. Or 2 times 1, 1 had no impact on multiplying it with, we still have 2. That means if E is an identity element, we say A star E, this one is not going to have an impact on this. Same applies, this star is not going to have an impact on A. Hence, our answer is going to be A. Okay, I think you understand this, guys. Because 2 plus 0, we get 2. And 2 minus 0, we get 2. 2 times 1, we get 2. And 3 times 1, we get 3. We are still remaining with the same number because 1 becomes an identity with multiplication and 0 becomes an identity with positive or minus with any number. Okay, so understand it from now to say that when we have A star E, if E is an identity, we are going to get our answer to be A. Same applies when we have E star A. We still get our answer to be A. So understand from here. This is what we actually mean. Things has no impact on any number when we are operating them at the same time, which we are actually calling binary operation. So keep in mind of this. Now we are going to understand what and how can we find an inverse after knowing the identity element. Okay, so now an inverse of an element becomes true with this. Let's say, for example, we were saying to say that A. Let me write something here like now we are talking about an inverse. About inverse, I don't know if it's the 5 or 4, doesn't matter. Numbering doesn't matter. So A star E, we are saying that is equal to E star A, where we are going to have A. Okay, so now in this case, let me write an identity element to be B. Okay, in this case, we can use any letter. Lettering also doesn't matter. Okay, so what we are going to do, we are going to say A star B is equal to A in this case. Okay, that means to say B, what do I actually mean? Okay, I actually mean to say this is same as now. Okay, let me just say B star A, which is giving out an inverse element here. Okay. Okay, so understand this. So if you have A star B is giving us an inverse element, or we have B star A is giving us an inverse element, understand that A is an inverse of B. Okay, I don't want someone to get confused here. Okay, I don't want somebody to get confused here. Okay, what we are doing is simple. Here we have E instead. Okay, so what we have here, when you say A star B or B star A, and this thing is giving us an identity element, okay, that number which has no impact, okay, it is not changing anything. Just understand that B is an identity, is an inverse of A, okay, it is an inverse of A. So we can write to say the inverse of A is equal to B, and this is satisfied that when we have A star B is equal to B star A is giving what an inverse, an identity. So that's why I was saying to say that when you are asked to find the inverse, first of all you need to show if an identity exists. So I'm going to ask, does an identity exist? So if an identity exists, then you go ahead and find the inverse, okay, which is very important. So let's go ahead and do a question. I'm going to do now a number of questions using from what we've just read. Okay, so the first question, I'm taking questions from your lectures, right? The first question is you said define star on Q, which is actually set of rational numbers by x. Sorry, you need to have x star y to be equal to xy over 5. So then we are asked to say test for the above laws. Test for above laws. So let's go ahead and talk about the laws. See the laws which we've just talked about. We first talked about the closure properties. We talked about the commutative law, associative law, distributive law, and identity law. Also, finally, the inverse law. So this is what we are actually going to discuss on, if each of the law exists. Okay, so now what is closure property tells us? Okay, the closure property, first law, we are going to talk about the closure property law. Okay, we were saying that if we take two numbers from a set, we still are going to have a number from the same set. Okay, we are doing a binary operation. So if we take two numbers, if A and B are member of set A, the answer which we are going to have C should also be a member of A. So this means to say that since the set you have been given is the set of rational numbers, if we take two numbers, let's say for example we say x, we are going to say let x be equal to 1, and we say x now 2, we say now y be equal to 5, or we say equal to 2. So now our x, you can make any assumption. I like using small numbers which are not going to trouble me when it comes to operations there. Star y is equal to, that means to say now x, where there is x here, we're going to replace 1, and where there is y, we're going to replace 2. So we're going to have 1 times 2 is equal over 5 there. We are going to get 2 over 5. So we're going to ask your question, is this a member of, is 2 over 5 a member of actually of rational numbers? Actually yes, because these rational numbers are numbers that can be expressed in the form of A over B, and actually 2 over 5 can be expressed in the form of A over B. If you missed a first video, the very first video I shared on that video, I was talking about the number system where we talked about all these numbers, starting from real numbers, natural numbers, even numbers, integers, irrational, rational. Please check out for that video on my channel. Set for that video so that you're hot and you may not get confused when we are actually talking about this. So since we are found to say that after taking two irrational numbers, the two rational numbers, 1 and 2, are rational numbers, because we know that 1 can be expressed in the form of 1 over 1 and 2 over 1. These are what are all rational numbers. We take two rational numbers and we get a rational number. Just understand to say that the closure property has been satisfied. Okay, so I'm going to say hence the closure property is satisfied. The reason is very simple, because after taking two rational numbers, we still get a rational number here. Okay, so what about the other row? The other row is commutative. I like starting with commutative row. Commutative law. Okay, so as usual, the expression that have been given is x star y is equal to xy over 5. So commutative law tells us to say a star b is equal to b star a. So in this case, we are going to take any two numbers there. So I'm going to say, let's say 1 star 2 is going to be equal to star 1. So I'm going to test this and this in this expression. So I'm going to say, well, let's start with this to be our left hand side. Let's test 1 star 2. 1 star 2 in this expression, that means to say this will become 1 and this will become 2. So I'm going to say 1 times 2 over 5, we get 2 over 5. Okay, let's now test to the right hand side. We have 2 star 1. Okay, 2 star 1, that means to say now x becomes 2 and y becomes 1, because what we are actually doing, we are actually doing x star y. So don't get confused on that. So we are going to say where there is x, we put 2 there, times 1 over 5. We still get 2 over 5. So as you can see, 2 over 5 and 2 over 5 are one and the same. So the left hand side is equal to the right hand side. So you are going to say that also commutative law here has been proved, has been satisfied after testing. The other law we need to understand is associative law now. It is actually 3. Associative law. Associative law actually talks about the order, guys. So we are going to say associative tells us A star B star C is equal to A star B star C. We already know the expression. We already know the expression is equal to x star y is equal to xy over 5. Okay, so what I want you to understand is this. We are going to say, we are going to rate A. We're going to rate A to be equal to 1, okay, B to be equal to also 1. We can rate B also be 1, and C to be 2. I like using small numbers. Okay, so we are going to start with the left hand side. Left hand side we have A star B star C. Okay, so what we are going to do is this. A star B, it means we are going to use 1 and 1 to replace in the expression, because we have to start with what is in the brackets. Okay, so what do we get? We get 1 over 5 there. So it's 1 times 1 over 5 star c. Star c is actually 1. Star c, because the c is actually 2 there. Okay, so we get 1 over 5 star 2. Okay, so what we do next, we are going to test also this using the same expression. That means where there is x, we replace 1.5. So we are going to have 1 over 5. Now y becomes 2 because this is y, this is x. So we multiply by 2 over 5. This means we are dividing by 5 there. Okay, so we get to have 2 over 5. And we divide by 5. Dividing by 5 is same as having 2 over 5 multiplied by 1 over 5, which are going to have 2 over 25. Yeah. Okay, so now after understanding this, we have the left hand side. Let's do the right hand side. The right hand side, we have a star b star c. Okay, so we start with what's in the brackets is b star c. Okay, that means to say, in this case, our b we already know is 1 and our c is actually 2. And this corresponds to y and this corresponds to x. That means we're going to replace 1, a is 1 star. There we get 1 times 2 because we have x times y, so we get 2 over 5. Now look at this. 1 star 1 over 5. We had 1 over 5 star 2. Here we have 1 star 2 over 5. So we have to do this also. So that means now this becomes x and this becomes y. So we are going to replace this on this expression. We are going to get 1 times this, we get 2 over 5. We are also dividing by 5 because we have over 5 here. So dividing by 5 same as 2 over 5 multiplied by 1 over 5 because we change here. We find the reciprocal as we are changing the sign. Okay, so we understand 5 times 5 we get 25. So looking at this and this are one and the same, so I'm going to say that associative is also being proved to be true in this expression. Okay, so the other thing we can actually what we are not going to prove distributive law, because distributive law can only be proven when we have two different expressions. Like I said, if we have star, okay, if we have star, for example, let's say we have star and o plus and minus at the same time. But in this case, we only add the star, so distributive law can't be proven in the case in our situation. So we go and use the identity law to be our number 5 in this case. I don't know if it's number 5. Numbering doesn't matter there. So the identity element. Let's say find the identity element. Okay, identity element tells us to say that A star E actually should give us A. Okay, say A star E should give us A. Okay, otherwise the expression already is x star y is equal to xy over 5. So now look at this. So that means to say where there is this, we replace this, and this we replace this. So we are going to have now, we are going to have where there is x we put A, and where there is y we put E over 5, but this is equal to A. So crossing multiply, we're going to have 5a. This times this, we get ae, then multiplied by 5a. Okay, so we can say we can solve for e by dividing a everywhere. So this is going to cancel. Our identity element becomes 5. So this is our identity element, and the expression is going to be true to say that when we put e here, when we say, because our expression is a, e over 5 is equal to a. That means to say when we say we put 5 there on top, we're going to have a times 5 over 5. So this and this is going to cancel. It's going to remain with here. That means this is not going to have an impact on this operation. That's why the identity element becomes 5. So this is our identity element. So this is how you test for the identity element. And in this case, the identity element what exists. Okay, let's go ahead now and talk about the inverse. Okay, as usual, we said the inverse is given by a star b is equal to e, where in this case we say that the inverse of a is actually b. So in our case, we already have the expression to be x star y to be xy over 5. So what we are going to do is simple. What we are going to do is very simple. So what we're going to do, we're going to say a for x and b for y. So we are going to say now, we are actually going to say we are going to replace y there is x, we say a, and y there is y, we put b over 5. Okay, we say to be equal to e, but we say but an inverse, an identity is equal to 5. That's why I said an identity is very important. You need to find it in the first place. So an identity element is 5. So I'm going to say a over b over 5 is equal to 5. So understand now this to say we want to find the inverse. We want to find the inverse. Okay, we want to find the inverse. So the inverse is b. I said the inverse is b. So we are going to make b the subject of the formula. So we say we cross multiply. This time this we get ab is equal to 25. This time this we get 25. So we divide by a. We divide by a. So our inverse b is equal to 25 over a. So this is how you find an inverse. And actually, as long as the identity exists, that means an inverse also exists. Okay, let's do another question, which is a different question. We see how far we can understand this. So now, this question I'll try by all means to be faster than the way I have been, because I've been slow. So the question is now define star on z. Actually, z is integers by the expression is x star y is equal to x plus y minus 1. Okay, so we are going to test for the laws. We are going to test for closure law, associative law, commutative law, identity law, and inverse law. Okay, with respect to the star which have been given. So let's start with the closure law. So integers, guys, or integers, these are positive and negative numbers including 0. Okay, so all positive or negative and positive numbers including 0 is the set of integers. So we're going to take to test for closure law, because we know that closure law, if we have two numbers which are integers, we must produce a new number which should also be an integer. Okay, so from an integer we can take two integers. So I can say a -1, we can take a -1. We are going to say x is going to be, let x be -1, and y be 0. Okay, so we're going to replace in the expression here. So we are going to say our x is the y. That means to say where there is x we put -1 here, and where there is y we put 0 minus 1, which is going to give us -2. So you're going to ask, is -2 an integer? Actually, yes. And because these two integers produce an integer, that means the closure property has been satisfied. As simple as that. Okay, let's now talk about commutative law. Commutative law. Okay. So commutative law tells us, in this case it tells us x star y is same as y star x. The order doesn't change. When you say 1 plus 2 is same as 2 plus 1, or 3 times 2 is same as 2 times 3. Okay, so in this case we already have the expression to be x star y is equal to x plus y minus 1. Okay, this is the expression which we have. So let x, we are going to test for, in this case our x is going to be 1. I like using small numbers. 1 star 0. Then since commutative law just changed the the order, here we're going to say 0 star 1. Okay, so with our left hand side, what we are going to have, we have x to be 1 and y to be 0. So we replace in this expression. So our 1 star 0 is going to have 1 plus 0 minus 1, which is actually 0. Let's go to our right hand side. Let's see something to our right hand side. Our right hand side, we have our y to be 0. Okay, our y to be 0. Am I doing the right thing here? We have 1 star y. Okay, and the y star x. All right, so since x is equal to 1 and y is equal to 0, so in this case, so what we need to do, we need to say we are going to have x to be 1 and y to be 0. So in this case now, in this case we are going to have our, where there is x, where there is x, we are going to put 1. Okay, or let me say in this case we are going to have, where there is x, we are going to, since we have 0 star x. Okay, this is x, this is y, and this is x, this is y. Okay, this is where I almost missed it. All right, so that means in this case our x is going to be 0 and our y is going to be 1. So our 0 star x is going to be, where there is x we put 0, and where there is y we put 1 minus 1, which is actually also 0. So as you can see, the left hand side is equal to the right hand side, and in this case the commutative law is also being satisfied. Okay, so now we can now just talk about the associative law. The associative law tells us to say that A star B star C is equal to, we can just change the order, and we can do any any change here doesn't matter there, as long as the expression is looking like this. I know the first expression I told you it is a star b star c is equal to a star b star c. But according to associative, these two are one and the same as long as the operation is star everywhere. This is just one and the same. So let me just go with the one I taught you in the explanation given area. I don't want to confuse anyone. So what you're going to do, guys, we're going to say this. You're going to have our a to be, let's say our a be 0. Our a is going to be 0 star, let me star 0 also. Let me have more zeros, then star 1. Okay, our a as usual is 0 star b. Our b we've also read to be 0, then c to be 1. Okay, let's test this too. So it is your first thing, guys. Let a to be some number, and the same a we have here, okay, so we need to know the order. If the order will still be the same, the expression already we have x star y to be equal to x plus y minus 1. So we start with what is in the brackets. Okay, we start with what is in the brackets to the left hand side. That means why there is x we put 0, and the way there is y we put 0. So when we put 0 here and 0 here, we get the answer to be -1. So we get -1 star 1 here. We brought 1 there. Okay, so now we can now use this to express in this expression. So what we have, we're going to have y there is x, because this is x, this is y as usual. So we're going to say y there is x, we put -1, and y there is y, we put 1 minus 1. Where when you answer this, you are going to have the answer to, because this is 0, so we're going to have -1 as our answer. So let's talk about this expression now. We have 0 outside. We start with what is in the brackets as usual. 0 star 1 is what we are from answering here. Okay, 0 star 1 was giving us 0. Okay, 0 star 1 was giving us 0. So let's now do 0 star 0. So that means this will become our x value and this is our y value. Expressing in this expression, where there's x we put 0, and where there's y we put 0 minus 1. Our answer still be -1. As you can see, this all the parts are the same, so associative law also it is also satisfied, or in Zambia we are now calling it kwenyu. All right, so we go now and talk about if the identity law exists. As usual, the identity law tells us to say a is equal to a star e. Okay, our expression is this. Our expression is that x star y is equal to x plus y minus 1. This is what we shouldn't forget. All right, so now let's look at this. So that means to say this becomes our x, and this becomes our y. So it is the matter of expressing in the formula. Okay, we express in the formula. So what are we going to get? What we're going to get, we are going to say this. We are going to say a is equal to what we get our, in this case now, this will be replaced by this. So we are going to, or this we will replace x. We are going to have a plus now e here, then minus 1. So what you do, we want to find the identity. Okay, we are looking at the identity here. The identity, okay, is what we are actually talking about. We want to see if the identity exists. So as usual, we solve for E because E is an identity element. So we take this to the other side, we're going to have A minus A. Then this will become positive 1. When you go to the other side, we remain with A. A minus A is 0 plus 1 is A. That means our identity element becomes to be equal to 0. Actually, is equal to 1, not 0. So our identity element is equal to 1. Take note, since we have the identity element, that means the inverse also exists. So we'll proceed to answering the inverse. If we didn't have the identity element, we can't do anything related to finding the inverse. So let's go ahead and do the inverse of this binary operation. Okay, so here is what we do. So the inverse law tells us to say A star B should always give us E, and the inverse is B. Very simple. The expression we have x star y is giving us x plus y minus 1. Okay, what information do you get from here? The information is very simple. Getting bored of let's try to use blue. Okay, so that means to say, as we can see, A is related to x and B to y. So what we are going to do, we are going to say now, this is going to be equal to this, but we are going to replace x plus y minus 1. So now what we are going to do, we are going to say why there is A. Okay, where there is A, we put, where there is x, we put A. Okay, where there is x, we put A, and where there is y, we put B minus 1. I said in the first place to say that the inverse is actually B. So we're going to make B the subject of the formula. So we're going to say this is going to the other side. So E, we're going to have, this is become negative A, and this becomes positive 1 is equal to B. Okay. But E is equal to 1. Let me show you. But E is equal to 1. This is the identity element we found. So where there is E, we put 1. Okay, we put 1 there. We put 1 minus A plus 1 is equal to B. That means to say 1 plus 1 we get 2. So we're going to have 2 minus A is equal to B. And since B is an inverse, we're going to say the inverse is equal to B. The inverse becomes 2 minus A. Actually, don't mind the circle ring. Don't know if I'm super excited or what's actually happened, I don't know. So this is how you find the inverse. So guys, you should be following all the steps. Like I'm trying to make things simple for you because you comprehend too much about binary operations, and I skipped the topic so that we may handle functions, because functions are the one which are mostly asked in your exams. This one will only have maybe 5 marks in your exam, but functions will carry about 20 or 30 marks in your exams, and you're going to testify this Sunday. You're going to have your test 1. Okay, so we go to the other question. What I want is to answer all the questions which are in this because the third sheet question I've answered for you. So what has just remained for me is just to answer for you these questions in the lecture slides. So the question is, relate the binary operation on the integers be defined by x star y to be equal to xy plus 5 for all x, y, for x and y as the members of z. So that means to say that x and y must satisfy this binary operation. So the first question is determine. Okay, the first question is determine. Let me write the question. You may like to screenshot. So determine for star -1 star 6. Okay, then our B is they're asking is star associative. I can give this as your assignment. Now let me do it for you. Since you are in a hurry preparing for test, I can't keep on hanging a burden on your neck, so let me just do this for you. Then 2, actually 3. The question is, does Z have an identity element with respect to X? Does the star actually is does Z, which is integers, as an identity element with respect to star? You read what I've just said here. Okay, so let's start by evaluating this. Okay, so as usual, the expression we have been given is that x is the y is equal to xy then plus 5. Okay, then I've been asked to determine 4 star -1 then star 6. As usual, we start with what is in the brackets. Okay, let's find 4 star -1. That means this becomes x and this becomes y. So it is the matter of replacing in the formula there. So why there is x, we put 4, and why there is y, we put -1 plus 5 there. So our answer, this is -4 plus 5, which gives us 1. Okay, so now what we do next is to, since we have 1 here, we are going to find now, this is going to be replaced by 1. We are going to say 1 star 6 is what you're going to find now. So that means this becomes our x and this becomes our y. So it's the matter of replacing now in this expression. So we say 1 multiplied by 6 plus 5, which actually we are getting 11. Oh, these things are very simple. Very simple, guys. When you meet this kind of questions, you shouldn't even struggle to handle. Okay, so the other question is a star associative? Is a star an associative binary operation? Okay, so let's see. Let's try to find if a star is an associative. Okay, so to find if a star is an associative, we use A star B star C is equal to A star B star C. Okay, so now here what you are going to do, I'm going to make things very simple. I'm going to write A to be 0, B to be 0, then star to be 1, C to be 1, A already 0, star 0, then star 1, because C is 1 here. Okay, so now let's test if this is true with this expression which have been given. X star y is equal to xy plus what's the expression, plus 5. we start with what is in the brackets. That means to say 0 star y, this is for x, this is for y. So x 0 times 0, we get 0 plus size, we get 5. So you can now do 5 star 1 because this is our 1 and this is our 0 star 0. Okay, so what we do next, we can say now this becomes our x and this becomes our y. So we say x times y, which is 5 multiplied by 1 now plus this 5. We get our 10. This is our left hand side. Okay, so now we can go to our right hand side. We see what is to our right hand side. As usual, we start with what is in the bracket, so 0 star 1. That means to say this becomes our x and this becomes our 1. Now look at this. So what we are going to do, say where there is 0, we put x, where there is 0, and y 1. So 0 times this becomes 0. Okay, because we already know that we already know to say that 0 times 1 becomes 0 plus that 5. So we get 5 here. So we are going to have 0 star 5 is what you are going to find. Okay, so let's go ahead and find 0 star 5. So that means this becomes our x and this becomes our y. Okay, so what we can do now is just to replace in the formula. X times y, it is 0 times 5, which is 0, plus this 5, which is 5. This is our right hand side. As you can see now, our left hand side in this case is not equal to our right hand side. So you can even say that star is isn't an associative binary. Okay, so the other question is does Z have an identity element with respect to X? Okay, so an identity element has been given by this formula. As since we started, A star E should give us E. I should give us I say this is an identity, so it shouldn't have an effect on A, so we are going to have A. As usual, the expression is x star y to be equal to xy plus 5. Okay, so as usual, so what we are going to do is very simple here. So to find the identity, so that means this becomes our x, this becomes our y. So we're going to replace here and here. We're going to say A times E plus 5 should equal to this A. So we want to solve for E because we want to find the identity here. Okay, so we are going to say this times this, we are going to have A times E is equal to A. Now this comes to the other side, becomes minus 5. So to get rid of A, we divide A everywhere so that this may cancel. So our identity becomes A minus 5 over A. Okay, so now when you look about this, the question was, does we have an identity with respect to integers? Okay, so this expression, battery is almost off. I don't know, I'm going to even to finish this question, the last question. Okay, so I'll try to be fast so that I try by all means to finish the question. So as you can see, this is not an integer. Integers are not expressed in the form of A over B. This can be a rational number. It's not an integer. So since this is an identity, is giving the other set instead of giving us an identity. So we're going to say that instead of giving us the integer, we're going to say that an identity doesn't exist. Doesn't exist. Okay, so now let's do the last question. How are first I finish before the. So we're going to rate. It's a very important question. I shouldn't. Let me just try to be fast. Let's start. And circle. I'm writing this to be a circle, be a binary, not zero. Don't write it. Don't read it as zero. Let's see. Read it as circle. Be a binary operation on z. The binary operation on z defined by x star y to be equal to xy over 5, and x circle y is equal to xy plus 5. Okay, so the first question is star distributive over all? Is star distributive over all? They are asking that, can we distribute star over all? Is distributive law true? Or when we distribute star over circle? Actually, this kind of a reader is not reading by an example. Sorry. Okay, so what we do, it's very simple. Let me start with, so the other question will be a different of this. So when they say is a star distributive